Hello, Honors Algebra. Mr. Lawrence here with your review lessons for over the break. I will have 4 of these put together for you. I'll do them in different parts. One will be on Chapter 7, the things we've done, and I'll actually front load you a little bit for what we're going to do when we come back from break. That way it'll be just like we don't miss a beat. One will be all about Chapter 6, which will involve absolute values and domains and ranges and things like that. One will be on Chapter 5, which you guys should be masters at by now. Slope y-intercept form, standard form, point slope form, parallel, perpendicular lines. And then this video here will be the stuff that we did beforehand. It will involve number systems, order operations, solving multi-step equations, and things like that. Okay, so let's get started. Let's talk about number systems. Hopefully, you know, this is peer review. I know we've played the number system game a couple times in the room, and you guys were pretty good at it. I was pleasantly surprised at how you retained it. And number systems was something we did way before we did the flipped classroom. Let's remember our natural numbers, okay? Our natural numbers, they go 1, 2, 3, and on forever. They don't include any fractions or decimals, no negatives, no zero, okay? Then we have our whole numbers, okay? Whole numbers start with 0. They're just like the natural numbers in every way, except they start with 0. And I'm going to have to pause here and reorient my board. Okay, things should work a little bit better now. And then we had the integers. The integers are where the negatives show up. Remember, the integers include all the wholes. They also include the negatives of the wholes. And they go on forever in both directions. They don't have a beginning. They don't have an end. Still, no fractions or decimals have shown up in our number systems yet. Then we get to the rationals. The rationals. Okay. And the rationals include all the previous number systems, but they also include all fractions and decimals. 2 types of decimals. Decimals that end, like 6.5 or 1.0, or decimals that repeat, like 1.7 repeating, okay? 2/3 is a fraction that would be included. They do include negatives. You know, they could include negative 7.42, okay? If you can write it as a fraction, it's rational. Now, they do not include the decimals that go on forever without repeating. Those are the irrationals, and I'll write those in a different color. Irrationals. Ir meaning not. Irrationals. They only include decimals. What am I writing? Let me rewrite that for you. Include decimals. And those decimals must not end nor repeat. They can't end, they can't repeat. Now remember, this is not a repeating decimal. 3.1415, 16, 17, 18, 19, 17, 3, 15. It is true that the 1 shows up an awful lot. It is true that the 7 shows up a couple times, the 5 shows up a couple times, the 3 shows up a couple times, but they are not repeating decimals. ... after the number means it goes on forever without repeating. Some other forms that they can take is the square root of 2, the square root of 3. Not the square root of 4, because the square root of 4 simplifies to 2. 2 would be a natural number. Square root of 5. Any number that is not a perfect square. By the way, it would not include something like this, 1.21, the square root of that. Because if you check that on a calculator, I think you'll find that it comes out to a decimal. It'll come out to a rational number. These here come out to decimals that go on forever without repeating. Okay? And together they make up the real numbers. And we had a little picture that you guys created for me. And it had the naturals in a circle like here, right? And then we had the wholes, right? And then the integers. And remember, for integers, they use a Z, strong Z sound in the word integer. On the rationals, we use Q for quotient because a rational number is any number that can be written as a fraction. Irrationals, they use an I. Okay, and of course, remember the most famous irrational number is pi. Very good for dessert. And then all together, they make up the real numbers, right? Okay, so let me see here. So that's the number systems. If I ask you to give, let's say you have -3/4, name all the number systems it belongs to. It might be handy to have a mental picture of that Venn diagram in your head and go through them all. -3/4 is, I'll tell you what, I'll write N, W, Z, Q, I, and R. Okay. Is it a natural number? Nope, definitely not natural. Is it whole? No. Integer, well, it's got a negative. Well, integers don't include fractions, though. Is it rational? It sure is. Is it irrational? Not possible. You can't have a number be rational and irrational at the same time. Is it a real number? Of course, we only deal in real numbers in this classroom. I might throw a non-real number out at you in class to see if you're understanding, but we only deal with real numbers in this class. So you'll Anyway, okay. What if we had a number, say, like, I don't know, the square root of, hold on a second. Let's do the square root of 169 over the square root of 121. Well, that's the same as square root of 169 over the square root of 121, which is the same as 13 over 11, which is a fraction. Okay? It's not a natural number. It's not a whole. It's not an integer, but it is rational, and it is real. Okay? Let's take a look at another example. How about something like this, where we have 20/4. Well, I can simplify that to 5. 5 is natural. If it's natural, it has to be whole, has to be an integer, has to be rational, has to be real. Okay? All right. So that would be that. Explaining the square roots. Oh, sorry about that. 1 second. I'm confusing myself. Okay, so that should be enough about number systems. If you want to ask a question in class, feel free to. All right, let's talk about some order of operations problems. Something like this. Remember, the order of operations, a lot of times we call it PEMDAS. Please, please, please do not ever use PEMDAS as a reason. Use the words order of operations, especially on the OAA that you guys will take in the spring. PEMDAS is just a mnemonic device that we use to help us remember, but it is not like an accepted math thing. So some people have never heard of it. Like, for example, Mrs. Haas had never heard of PEMDAS except until she came to Ohio. All right, so I'm going to do the order of operations. I'm going to follow parentheses first. And I'm going to look in here, and there's actually nothing to do in this parenthesis, right? Now, there's something in here to do. There's addition inside these brackets, but this exponent here takes precedence. So it looks like for this particular problem, the first thing I'm going to do is all my exponents. I have an exponent here, and I have an exponent here. I'll take care of those right away. All right, so 5 squared will become 25. I'll have minus 20 divided by 4 plus 5. Now, -1 to the third power is -1 times -1 times -1. Now, please, 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 you're allowed to use a calculator on the midterm. Don't just think you know it. Check yourself. I love the fact that some of you wanted try it without your calculator, but then check your answer. Some of you get the simplest things wrong because you don't ever stop and take the time. You just go, oh, I know it. And then you go on for years and years and years doing it wrong until finally it clicks. Check on a calculator. If you're not sure that -1 to the third power is -1. I have a double sign situation going on there, but that's okay. All right, so now I'm going to back up in PEMDAS in the order of operations. I'm going to go back to parentheses because these guys count as parentheses. So I have 25 minus 20 divided by 4 plus 4. And I drop my parentheses out because they're no longer important. All right, now I have subtraction, I have division, and addition. I will do the division first. I will do this part of the problem first. So I will have 25. Now I can think about this as a -20 divided by 4, or I can think about it as minus 20 divided by 4. Either way, I'll come up with 5 there, and there'll be a negative, and then plus 4. Now remember, when the problem is all addition, subtraction, or all multiplication, division, I do not do one before the other. I go left to right. So I'm going to do 25 minus 5 plus 4. Well, this is 20 plus 4 is 24. My answer is 24. All right. I do not do 5 plus 4 and then do 25 minus that. No, the order of operations states that when it's all multiplication, division, or all addition, subtraction, I go left to right. All right. Let's give you a couple practice problems here. Hold on one second. Okay, you can go ahead and try these two problems on your own. Pause the video. When you're ready, unpause and see how I did on them. If you're unpausing, you're ready to see my solution. On problem number 1, I'm going to do my division first, and I will get 4 times 7 minus 8 plus 1. I will do my multiplication next and get 28 minus 8 plus 1. I'll do my subtraction and get 20 plus 1. This will equal 21. Hopefully you got the right answer. All right, problem number 2. If you haven't gotten a solution yet, go ahead and pause. Otherwise, let it roll, and I'm going to do it next. I'm going to do my multiplication first. So it's going to be 5 minus 16 plus 20. Quantity cubed. 5 minus 16 is -11 plus 20. And then I'm going to get a positive 9 to the third power, which means 9 times 9 times 9. Well, I know 9 times 9 is 81. 81 times 9 will be 729. And there we go. Okay, moving on to the last type of problem, and then that will wrap up this first winter break video. We're going to solve some different types of equations. I'm going to put 4 different types of equations up. One will be a 2-step equation. The other 3 will be multi-step. And we'll talk about each one of them, and then you guys can relax from this video. All right, so the first type of problem is going to be a simple, let me see here, 5 minus 3x, and that is going to equal 17. Okay, when I go to solve this, I'm going to listen to Saddam, right? I see a 3 attached by multiplication. I see a 5 attached by addition. Why addition? Because the 5 is positive. So my first step will be to subtract 5 from both sides. I will get -3x equals 12. I'll divide by -3. X will equal -4. And I'm done. I can check my work. 5 minus 3 times -4. Okay, 5 minus -12, which is the same as 5 plus 12, which equals 17. And that's what it's supposed to equal. That's the first type of problem. Okay, problem type 2. 3x minus 1 over 2 equals 5. Remember, I can't get rid of that minus 1 there. I can't do it. I'm not allowed. It's not really a -1. Remember, it's 3x over 2 minus 1/2. That's the real problem that's going on. If I could get rid of that denominator, oops, wrong place. If I could get rid of that denominator, then I could solve it just like the previous problem. The denominator means divide. To undo division, I am going to multiply. Multiply both sides by the denominator. The right-hand side becomes 10. The 2's cancel, leaving me 3x minus 1. 3x will equal 11. Dividing by 3, x will equal 11 thirds. Or you could give me an answer of 3 2/3. Either one would be acceptable. Okay, hopefully you're pausing these, trying to do them on your own. All right, let's try here. Number 3, how about this problem? 2/3 x minus 5 equals 7. This is a great problem to do two different ways. One, you could add 5 to both sides and then divide each side by 2/3. Some of you are getting really good at that. Copy times flip. Or you can multiply everything through by 3 and then go ahead and solve it. I'll do it both ways. Why don't you go ahead and pause and do it the way you want to do it, and then I will run through both solutions, okay? If you're still listening, I assume you're ready to see a solution. In this first problem, I will add 5 to each side. I'll get 2/3 x equals 12. I'll divide by 2/3. Divide by 2/3. X will equal 12 over 1 times 3 over 2. Okay. 18. X is equal to 18 is my solution. If I choose to multiply everything through by 3 to begin with, those will cancel, giving me a 2x minus a 15, and that'll equal 21. I will add 15 to each side, getting 2x equals 36. I'll divide by 2. X will equal 18. I have to get the same answer no matter how I do it. Okay, the last type of problem I would like to go over is one with variables on both sides. So this is example 4. We might have 6 times the quantity of 2x minus 5. Oh, let me see here. Let me make that plus 10. And then that will be equal to, say, 10x plus 8. Okay. If you want to try it on your own, pause the video. I think that's a great idea. Right now, I will distribute my 6 to get 12x minus 30 plus 10. That'll equal 10x plus 8. On the left-hand side, I notice I have some like terms. I have a negative 30 and a positive 10. I will combine my like terms to get 12x minus 20, which equal 10x plus 8. I don't like the fact that there are x's on both sides of the equation, so I will take one of the x groups away. Remember, it is often easier to subtract the smaller x. Okay. And now it's just a two-step equation. I'll add 20 to each side. I'll end up with 2x equaling 28. X will end up equaling 14 when I divide by 2. There we go. Now I gave you a review sheet. You feel free to go ahead and do some of these problems. Okay? Check out page 1 of the review sheet. It has practice problems of this type. See what you can do with it. All right, this is the end of your first video. Mr. Lawrence signing off.